Okay, this problem says we have a charge Q that is uniformly distributed over a volume of uniform ball of mass m and the radius r, which rotates with angular velocity omega. So what we have, so if you see, we have a uniform sphere, and this is a ball, a spherical ball, and it is filled with a charge, positive charge. And now this total charge, let us say the book write a small q, let me write capital Q because I deal with the capital Q. So this is the total charge capital Q that is uniformly distributed in this volume. Now this ball has a mass m and radius of the ball is capital R, and this ball gets rotated about vertical axis with angular velocity omega, and we have to calculate what is the magnetic moment of this system. So we have to calculate magnetic moment. So we want to calculate magnetic moment. How will you proceed? What is magnetic moment? This is basically vector I into A. Right now I am interested in magnitude, so simply mu is equals to I into A. And basically if you see, all this vector will add. So if I say how we'll proceed, so what we will do is we will take a disk here, and due to this disk, magnetic field or dipole magnetic moment in this direction, another disk, dipole moment in this direction, another disk, dipole moment in this direction. So these all are having same area vector, so they can be simply added. So this means now I can say I will find d mu, and they all are having in the same direction. So if I add all these d mu's, I will have mu, that is dipole moment. So this is my idea. So what I will do is, so this is my disk, this is my sphere. So let us say this is my sphere. Are you getting? Now, if I take a disk at radius r, now this time this is a disk, this is not a sphere, mind it. So this is a disk at radius r and angle theta. So this angle is theta. So basically if you see, we can make another diagram. So you will having a disk of radius a small r at angle theta. So this angle is theta. We can calculate what is the radius of this disk. This is theta, this is r. So this is r sine theta. So the radius is r sine theta. Are you getting or not? So this is the radius. Now if I consider another, that is r plus theta plus d theta. So if I consider next elemental ring, so I will be having something like this. So this is at my theta. So this ring I have made at angle theta. Let us make next ring at angle of theta plus d theta. So if I make the next ring at angle of theta plus d theta, I will having something like this. So this is at theta, and this is theta plus d theta. So we can calculate what is the thickness. You see, thickness will be this. So what is the thickness of this disk? So this is the thickness. Are you getting or not? So this is again r d theta is the thickness. Thickness of disk is r d theta. What is the volume of this disk? So let me calculate volume of elemental disk. So volume of elemental disk. So this will be area times thickness, and now I know area. Area is pi r square, r is r sine theta. So this is pi r square sine theta. So area is pi r square, and into thickness. What is thickness? So this thickness is basically r d theta. R d theta. Now let us calculate what is the charge. So charge on elemental ring. So let us calculate charge over elemental ring. Charge over elemental ring. So what will be the charge? This is the area multiplied by, this is the volume multiplied by the rho. Let us say rho is the volume charge density. So I have to multiply rho into pi r square sine square theta, and this is r d theta. What is rho? So rho is basically volume charge density. Total charge is q, and the volume is 4 by 3 pi r q, capital R q. So if you wish, you can plug the value of rho there. So let us plug the value of rho. So if I plug the value of rho, that is q, 3q by 4 pi r q. So this becomes, and here I will have pi into r q. This r square and r becomes r q sine square theta d theta. So if I cancel out the terms, what I will have? So I will have this pi goes, RQ also goes, so I will have 3q by 4, RQ goes, so simply I will have sine square theta d theta, sine square theta d theta. And now I will use the result. This is the total charge over this elemental ring. Are you getting or not? So if we have a ring and this contains a charge q, and let us say this ring is rotated by angular velocity omega, we have to calculate magnetic moment. What we have to calculate? We have to calculate magnetic moment. So if we have a ring and this ring is rotated with angular velocity omega and this has a charge q, then magnetic moment of this system is given by, mu is given by, so magnetic moment of this system is given by one by 4 q omega r square, where r is the radius. So let us say a square, where a is the radius. So this ring has the radius a. Now I will use the same thing. I have a disk here. This disk. You see, I have a disk here. I know the charge for this disk, so I can calculate. So for my purpose, what will be the d mu? I can write this will be 1 by 4. Charge will be dq omega. And what is my radius? Radius is r sine theta. So this is r sine theta. So this is r square sine square theta. Are you getting or not? And now I have to plug the value of dq. dq is 3q by 4 sine square theta d theta. And this multiplied by omega. So let us say omega I can write here. So omega I can write in the beginning also, because this is a constant, into r square again I can write in the beginning, and into sine square theta d theta. So we will have sine 4 theta. So this is again sine square theta. So I can write all the term at one place. So this becomes 3 by 16 omega r square q sine 4 theta d theta. Are you getting or not? So this is the magnetic moment you will have. If you simply, now you have to integrate this one, and then you will get the total moment. So if you want to get the total moment, you have to integrate this thing. So this is 3 omega r square q, this divided by 16, and then you have to integrate 0 to pi, and sine 4 theta d theta. Are you getting or not? If you see, I have done one mistake. Can you tell me where I have done one mistake? mistake I have done in taking the thickness of this ring disc. This disc thickness is not r d theta. If you see, this length is r sin theta. What is this length? This length is r cos theta. So if I call this length is r cos theta, let us say this length is x and this is basically r cos theta. I have to write slide early. So x is equals to, this is r cos theta. So what is dx? So dx is in this direction. What is the thickness? So now dx is, x is r cos theta. So dx is not r d theta. So x is r cos theta. Let me write here. If x is r cos theta you have, then dx will be, this is minus cos theta, differentiation is sin theta. So this is minus r sin theta d theta. So what is the mistake I have done? I have taken this is equals to r d theta. That is not basically same. So width is minus r sin theta d theta. Initially I have taken this is simply r into d theta. So everywhere I have to multiply with minus sin theta. Are you getting or not? So you see, so thickness is minus r sin theta d theta. So this term I have multiplied simply by r d theta. I have to multiply minus r sin theta d theta. So let me multiply minus sin theta here. So no change. Everywhere I will have minus sin theta d theta multiplied. So in place of where you have this, here again. So you see sin square r d theta. So wherever you have d theta, you multiply by minus sin theta. So you have here minus sin theta. And this happens many times because when you are doing, it does not pay much attention. So everywhere you will have, wherever you have d theta, you multiply by minus sin theta. Here I have d theta. So here again I have to multiply by minus sin theta. Here again I have d theta, multiply by minus sin t theta. So finally what you will have? You will have minus sin 5 theta. So let us say minus sin, if I take outside, and this sin 4 becomes sin 5. So let us plug here sin 5. So this is simply sin 5 theta d theta. Now integration, we have to integrate this one. So let us integrate sin 5 theta d theta separately. So I have to integrate sin 5 theta d theta. So how will you proceed? So let us say if you take sin 4 theta, now this is it completely mathematics, into sin theta d theta. And now I can write sin 4 theta is 1 minus cos square theta whole square. So 1 minus cos square theta whole square sin theta d theta. And now put z equals to cos theta. So if I put z equals to cos theta, so this becomes dz is equals to minus sin theta d theta. Are you getting or not? So this is minus sin theta d theta. So I will have, so this becomes, my integration becomes 1 minus z square whole square, and this is sin theta d theta, so I have to plug minus sin, this is dz. So this is simply minus 1 plus z4 minus 2z square, and then I have to integrate with dz. Are you getting or not? So this is the integration. Everybody agree or not? Now I have to integrate this one. So let us do improper integration first. So if I do improper integration, so this is minus, so let me put minus sign. So I will have, this is equals to minus dz. So this is my first integral, minus z4 dz. This is my second integral, and this is minus 2, let me take outside, z square dz. If I integrate all these terms, so dz is simply z, and everywhere I have minus. No, there I will have plus. This is minus, minus becomes plus. Are you getting? So dz is simply minus z, and z4 is z5 by 5, and this is plus 2z is zq by 3. And now let us plug this value. So z is my cos theta. So z is my cos theta, I see here. So z is cos theta. So this is minus cos theta to the power 5 by 5. So this is more mathematics. Are you getting or not? So this is cos, but okay. Cos q theta divided by 3. And I have to integrate this from 0 to pi. So let us integrate from 0 to pi. So everywhere we have limit. This is again 0 to pi. This is again 0 to pi. So if I do this limit, so this is minus. Cos pi is minus 1, cos 0 is minus 1, minus pi is basically minus 1, so you will have minus 1, so let us take 1 by 5 outside, so you will have minus 1, and this is plus, let us take 2 by 3 outside, so what you will have? You will have cos pi again minus 1, and cos 0 is 1, so this is the value you will have. So if you do all these values, so you will have minus plus 2, and here you will have minus plus, again plus 2 by 5. Let us check, are you getting same thing or not? So in this will we have 4 by 3. And now if you take LCM, so what you will have? You will have, if you take LCM 15, so let me write here itself. So you will have 15 into 2 30 minus 5 into 3 into 2, so 6 plus, this is plus 6. And this is 3 into 5. So 5 into 4, 20. Let me check whether things are right or not. So this is my integration. So I will have 36 minus 20. So this is 16 by 15. So now I have to put this integration limit, integration value here. So you have final answer, that is integration, integrable form here. This form. Are you getting or not? So what this value comes out to be? So this comes out to be, so 0 to pi if I integrate, this comes out to be plus 16 by 5. So I have to plug this value, plus 16 by 5. So if I plug this value plus 16 by 5 here, so you see what I will have. So this is, let me write here itself. So if I write this limit 16 by, so this is minus 3 omega r square cube divided by 16 or 16 by 15. So integration limit is 16 by 15. So what we will have? So this 16 goes, so we will have minus 3 by 5 and 3 by 15, so 1 by 5. So this is simply minus 1 by 5 omega r square cube. Why I am getting minus sign? Can anybody tell me? This minus sign is coming because I have taken different sign of x and theta. You see here, if my theta increases, my x decreases. If I would have taken x from the top, my x will also increase and theta will also increase. In that case, I should have got plus. Or I have done another way. I have integrated this from 0 to pi, pi to 0. In that case, if I have pi value, this theta decreases, pi to 0, my x increases. So this minus sign does not have much meaning. This is coming only because of this integration sign. So now I can say the value of magnetic moment is 1 by 5 omega r square cube. 1 by 5 omega r square cube. So this is the magnetic moment value. So this is important part. So I am really interested in magnitude. So what is the angular momentum? So this is a magnetic moment. Angular momentum is I into omega. Ball has a moment of inertia 2 by 5 mr square and r is capital R and this is omega. So what is the ratio mu by L? Question also asks, calculate mu by L. So this is 1 by 5 omega r square cube. So this is 1 by 5 omega r square cube. And this divided by this value 2 by 5 m r square omega. So r square omega cancels out. So we will have simply 1 by 5 also cancels out. So we will have 1 by 2 q by m. And this is a general result. So ratio of magnetic moment to the dipole moment, magnetic moment to angular momentum. This is given by q by 2m. This we have also derived in classes. This is used to discuss Bohr magneton also. Are you getting or not? So we have discussed in the class, that is mu by L is equals to E by 2m. In Bohr orbit, if an electron is revolving in a circle, it will have this value. Important one.